Hi, I'm Sam Redman. This is my progress review video for my final year project for module CO3808. I'm currently working towards making a rod of LEDs which will have attached to it a Raspberry Pi which will scan for wireless networks in range and will probe for their the signal strength, the received signal strength of a specific SSID. That signal strength will then be represented by the LEDs on the rod, with the more LEDs showing, the stronger the signal strength, and the fewer LEDs showing, the lower the signal strength. This is then captured over time through image, through a method called light painting, which will be used in order to analyse the elements which affect wireless signal strength in wireless networks. So the progress I've made so far is that I've installed Raspbian on a Raspberry Pi, which, as specified in the technical plan, was going to be the distribution used. We've discovered a method of scanning the wireless networks and storing the RSSI value of a specific SSID. Then also found a method of interfacing with the GPIO pins, and I've also wrote a batch script which will use the methods discovered to scan for the wireless networks and to store the RSSI, and then using that data found will plot, so it will turn on or off the LEDs through the method of interfacing with the GPIO pins, and then to actually output onto, I've built a test circuit which has 5 LEDs on, which either turn on or off depending on the signal strength. I'm just using a breadboard to create a demonstration circuit for the LEDs. So these cables here are all connected to GPIO pins of the Raspberry Pi. This red one here carries a 5 volts across to a common rail on the breadboard, which is then connected to a resistor, which then connects to the negative side of each LED. And then these 2 green cables, 2 white cables and a black cable each connect to the positive side of each LED. And then the Wi-Fi up here is used to scan for wireless networks, and then the script at the moment takes a specific SSID, and then depending on the RSSI received of that specific SSID, the script will then enable or disable one of these pins, which will either light or unlight the LED. So at the moment, the red pin is a weaker signal. That's a signal of around -75, and then the green LED up here represents a strong signal. So that's around, at the moment, I think it's -61 dBm, and then each LED represents a signal of around 3 dBm. So after showing you the demonstration, these are the problems which I've had to overcome in order to get a working implementation with 5 LEDs. So what bash script has been run in order to start scanning, it has to run a command which is called WPA CLI. This data couldn't be used in my implementation because of the fact that it displays certain flags that the SSIDs carry, and different SSIDs obviously have different encryption methods, which to format the output of this through a method called awk formatting. So awk will take the output and assign a different operator to each output. So in the typical output here, the first output, so where it says on each line this is, so selected interface WLAN 0, selected would be operator 1, interface would be operator 2, and WLAN 0 would be operator 3. So this means that you could consistently select certain operators, so I knew that operator 3 would be the signal level, because it would go service set identifier, BSSID, then the frequency, then the signal level, and the last one would always be the service set identifier. This was then formatted into what you see at the bottom, which is output after formatting. So that data can then be saved in an array, and then through the batch script that can then be looped, searching, and it will search for the specified SID, and then it knows that the index before that of the SID found will be the signal level. The method of interfacing with the LEDs is wiring pi, which is a library that's been written already for use of interfacing with the GPIO pins of the Pi, and there's lots of different uses for this, and another use for it will be with shift registers, which will also be discussed later in the video. So here's the script that I've written. The first section here, where it's highlighted in yellow, simply sets the GPIO pins using wiring pi. So you can see here it's just a for loop that sets 5 pins into output mode, so that then they can be used to be set either on or off. The next bit, the highlighted in yellow, which is painting, is just the string used, which will be searched for so that when testing in the field can specify a specific SID, so that it will only search for that SID. The next command, which is WPA CLI scan, that simply selects the YPi and scans with it, so that then the results can be gathered afterwards. This line, which is networks equals WPA scan result and awk print number 3 and number 5, that builds the results of the scan and formats them as discussed earlier, so that it was just the RSSI value, which is $3, and the SID name, which is $5, and it stores them into an array called networks. The next loop, which is a for loop, searches through the networks array for the string which is specified, so that only that string is looked for. This is the case statement, which is just made so that depending on the value received, only certain LEDs are lit. So although progress has been made, there are problems with the current test model. There's only 5 LEDs running, which doesn't give a very good resolution, so the sensitive changes in signal strength can't be go unnoticed, as each LED represents a possible change of 3 dBm. So the technical plan expects that the resolution would be defined by the amount of outputs that could be produced by the Raspberry Pi, and multiplexing will hopefully allow an output resolution of 64 or maybe even greater LEDs. So that needs to be overcome, and that will be overcome using shift registers. Another problem is that it's not currently battery powered. Now, the other problem is that it's not currently mounted on a rod because of the fact that it's on just on a breadboard at the moment. There's no sort of individual circuit which could then be placed onto a rod. So the problems which need to be solved over Christmas are to implement multiplexing using shift registers. So to use the breadboard with the shift registers in order to get a possible 32 LED output, and then maybe moving on to even trying to get 64 LED output, and then from that moving on to a standalone circuit which could then be mounted to a rod further on in the project timeline, and to experiment with powering the LEDs via battery power. I hope that I've been descriptive in saying what progress I've made with my project so far, and I hope you enjoyed the video. Thanks.